Conduction. Heat transfer is the process by which thermal energy is exchanged between different objects or regions. There are three primary modes of heat transfer: conduction, convection, and radiation. To help illustrate these modes of heat transfer, let's make a trip to Mrs. Sozie's home as she makes some tea. Charcoal produces heat, which is then transferred to the surrounding environment through different modes. Conduction occurs when the heat is directly transferred between the stove, saucepan, and water. Convection occurs when heated water circulates within the saucepan. Mrs. Sozie feels the heat as a result of radiation. Let's carry out an experiment to explain how heat is transferred through conduction. A student puts wax on heads of 3 pins. He then sticks the pins so that they are evenly spaced along the steel rod. The end of the rod is then heated, and in a few minutes, the heat is transferred from one end to another. The wax melts and the pins fall off one after another. As the molecules are heated at one end, they speed up and vibrate more. The molecules transfer energy to the molecules next to them, which then get excited and move more rapidly. The molecules in turn excite the molecules next to them, and so on. In this way, heat energy is passed from molecule to molecule. Conduction is the flow of heat from a region of high temperature to a region of low temperature without the movement of matter itself. The rate of conduction depends on several factors, including the type of material, its thermoconductivity, and the temperature difference between the two objects in contact. Let's carry out an experiment to compare the rates of conduction by different materials. We are going to use equal rods of glass, aluminium, iron, copper, and steel. The rods are then coated with wax. The rods are then inserted into our special container with holes and hot water. The wax melts off the rods. However, different quantities of wax melt off each rod. Copper has the least iron wax, followed by aluminium, then iron and steel. The glass has the most wax still coated on it. Metals have higher thermal conductivity compared to materials like glass or wood due to the nature of their atomic structure and the behavior of their electrons. In metals, the atoms are arranged in a closely packed lattice structure, and their outermost electrons are relatively free to move within the structure. These mobile electrons are often referred to as a sea of electrons. As these electrons move randomly within the metal, they collide with atoms and make them vibrate faster. In this way, thermal energy is rapidly transferred to all parts. Materials in which heat can travel easily are good conductors, whereas materials in which heat cannot easily travel are poor conductors of heat. Liquids and gases generally make poor conductors, so they are good insulators. We are going to carry out an experiment to show that water is a poor conductor of heat. In this experiment, we are going to use ice cubes wrapped in wire gauze, test tube, Bunsen burner, and a test tube holder. Ice cube wrapped in gauze are dropped in a test tube filled with water. Heat the water at the upper end of the test tube. What observations can you make from this experiment? The water at the top is boiled with the ice not melting. The water at the top is boiled with the ice not melting. Mercury is a liquid. However, the rate at which it conducts heat is different from the rate at which water conducts heat. Let's carry out an experiment to compare water and mercury as heat conductors. In this experiment, we are going to use 2 identical test tubes containing water and mercury and a Bunsen burner. Pins are attached to the bottom of the test tubes using wax. The first test tube containing water and the second containing mercury. The copper wire is then heated in the middle. Make some observations. The pin on the tube with mercury falls off fast.